Okie dokies, artichokes, let's get started. So we are going to be going over the problem Chubby Bunny, or 541. Hopefully you've read this and responded to the slide previous to this video. Personally, I think this problem should be called Someone Who Feeds Their Pets Way Too Much Food. But you know, it's not up to me. Anyway, problem Chubby Bunny follows two animals. We have a bunny and a cat, both of which are going to be grossly overweight by the end of this problem. So, just like we did in 522, we are going to create two equations based on the word problem. So, in the word problem, it says that Barbara has a bunny that weighs 5 pounds and gains 3 pounds per year. So, the gains 3 pounds per year is a really important one. That tells us two things. It tells us, one, that M, our growth, is 3 because they gain 3 pounds. It also tells us one of the units we're working with. We're working with years. Okay? The next part of this problem I want to look at is the very beginning of that sentence. Barbara has a bunny that weighs 5 pounds. Okay? So she's already said that we gain 3 pounds per year, but she states that they weigh 5 pounds presently, which means that is our start. 5 pounds. This also tells us two things. It tells us that our other variable is weight. So right now, in this problem, we're going to be looking at year, so time, and weight. Now that I have all my pieces together, recall that we're using the equation y equals mx plus b. So I have 3 for m, I'll replace that, plus 5. So that is my equation for bunny. So let's take a look at cat. Her cat has 19 pounds and gains 1 pound per year. So I know that my n is 1 because she's gaining 1 pound per year. And my b, she states that the cat is currently 19 pounds. Now, some word problems, and actually most of them, won't say that they start with, right? In this problem, we are going to have to kind of infer when she says the cat weighs 19 pounds that is where we're starting. That is where the cat started when we first started keeping track of its weight. Now, I don't have cats, so I don't know if 19 pounds is a lot. You'll have to email me and tell me if that is a really heavy for a cat, because that seems really heavy. Like, that's heavy for a baby, so I don't know. You'll have to tell me. Anyway, I've had this brought up a couple times. People have asked me, do they need to write the 1 in front of the x? Or there's been problems where it's x plus 19, for example, where there's no 1, and they're like, oh no, where's the growth? There's nothing in front of x. There is. It's a 1. It's because when we write problems like this, we're implying that's just a single x. If it was 0 x's, the x's wouldn't be there in the first place. This implies 1x, this implies 3 x's, right? So you don't have to write that 1 in front. If you're more comfortable doing that, feel free to, but just know that some problems are going to pop up like this. If you see nothing in front, it means 1. So growth will be 1 in this case. Okay, so now I have both of my equations together. So the first problem we're going to tackle on Nearpod is what variable belongs to what unit, year, or weight. So on Nearpod, I want you to tell me, do you think x is year and y is weight, or do you think y is year and x is weight? Okay, let's see if you got it correct. X is year and y is weight. Let me explain why x is year and y is weight. Okay, so first of all, x is normally the time frame. If you have minutes, seconds, weeks, years, that's going to be x. 9 times out of 10. If you're dealing with time, it's going to be x. But if we take a look at the problem here, we have 3x and 1x. What this right here is saying in context of the word problem is that the bunny gains 3 pounds each year. So if x is years, then if I do 1 year, right, 1 times 3 is 3. So the bunny gained 3 pounds. If I do 2 years, I would do 2 times 3 is 6. So in 2 years, the bunny gained 6 pounds. That's what that piece right there is telling you. What this piece is telling you is that they started with 5 pounds. So in 2 years, you can't just say the bunny weighs 6 pounds because he definitely started heavier. So he would weigh 11 pounds because he started at 5. But he's gained 6 pounds. That's what that piece is telling you. So that's how you know that X is the year, because of that modifier there. Okay, and if X is the year, that means that Y has no other choice but to wait. So we're going to get started on our problem. Okay, I talked about this in 5.2.2's intro video. EVM, or equals value method. Could be equal value method. Actually, I think that's it. I always feel like there's an S thrown in there. Equal value method. The last sentence of this problem is, when will the bunny and the cat weigh the same amount? So what I'm looking for is figure out when is Y the same for both of these problems. Or both of these equations, sorry. Because I want to assume that Y is the same, what I'm going to do is I'm going to do 3x plus 5 equals 1x plus 19. Because I want to know when these two are equal. I want to know when Y is the same number. So when are these two equal? And to do that, I'm going to solve, just like I normally would. If you do not have equations down by now, please come ask questions, because this is one of the last ones I'm going to explain equations. After this, we're just going to assume you know them, so please come ask questions. I always recommend to you guys to move the smaller ones first. I've explained this numerous times before. I do this so that we can avoid negatives. Because if I moved the 3 and subtracted that from both sides, I ended up with a -2, which is not what I want. I want no negatives. But if I move the 1, I end up with a positive 2x. Exactly how I like it. Okay, let's have some fun. Let's switch colors up. I have my x's isolated, so the next thing I need to do is get my units all on the same side. So I do the opposite. I have 2x equals 19 minus 5 is 14. The very last step in all equations is what? Division. Hopefully you said that. Or sort it. They're the same thing. We're going to divide by the number of x's. I had 2 x's equal 14 units. I want to know how much 1x equals. So if I divide by 2 on that side, I'm left with a single x. 14 divided by 2 is 7, so 1x equals 7. And in this case, because we know x equals years, we know that 1x equals 7 years. It's really important why you need to know what x equals, so that you can put those kind of units there. So we've answered the problem. The bunny and the cat will weigh the same amount in 7 years. Now, I don't know about you, but I'm curious to see how much will the bunny and the cat weigh, because I think they're going to be grossly overweight and in danger of some serious health problems. So let's find out. Again, I have never owned a cat nor a bunny, so please tell me if they are actually a perfectly normal weight, and they won't be dead. Okay, so the bunny had an equation of 3x plus 5. So we're going to replace x with 7 because I want to know in 7 years how much will they weigh. And then in the cat's case, we're going to replace x with 7 as well, because I want to know how much the cat will weigh. They should weigh the same amount, if I've done this correctly. Okay. 3 times 7, oh, sorry, I'm off my paper. 3 times 7 is 21. 21 plus 5 equals 26. Okay, so the bunny weighs 26 pounds. Let's see if I did this correctly. 7 plus 19 is 26. Perfect. So the cat will also weigh 26 pounds. So I did this correctly. They both weigh the same amount. So you'll have to tell me, is 26 pounds way too heavy for a bunny and her cat? I don't know. You'll have to let me know. Anyway, we've answered the question. In 7 years, the cat and bunny will weigh 26 pounds. Okay, if you have any questions, please ask me. Otherwise, this is how you use equals values method. And then I will see you in the outro video. Goodbye, and good luck.